All right. I see we have quite a few people for a Friday morning, but I'm just going to wait another 5 or so minutes and then we can get started with the lecture.
herkese
Alrighty, let's get started. Good morning. Okay, I'm just going to share my screen. Can everyone see my screen? Awesome. All right, so the structure of today's lecture is going to be a bit different than usual. And what we're going to do, so right now it's like 8 a.m. So from 8 to 12 today, we will be covering a few things. So we won't really have the traditional lecture lab split. From now until 12, we'll review a few key concepts. We'll take up questions, so we'll just cover a few key concepts over the rest of this lecture. We'll take up any questions you have about lecture or lab, basically everything we've learned over the last week. And once that's done, as you can see here, there are a few exercises we should go through together, just online. I think that would be really solidify our learning for last week. And once that's done, we are going to be making a video game together on VS Code. So that'll be fun. And then from 12 to 3, we'll have an extended break. And then after that, from 3 to 5, we have open office hours on the same call that this lecture is being held. And so during open office hours, we can take any questions like even like setup, so setting up node or prompt, and these other things, we'll work through that. But more specifically, like these questions are related to lecture and lab, and also like, concepts that we learned during lecture. So yeah, the main focus of today is just to review everything we've covered this week, because we finished all the concepts that we wanted to cover this week. So we're going to take this day to do a full review, and it's an opportunity for you guys to ask concept-related questions. So before we begin, actually, let's just cover a little bit of what we did yesterday. And I think we'll start with while loops. So when while loops were discussed, they follow this format of us having while, and then we have some condition here, right? And as long as this condition evaluates to true, we will keep running the code that is inside of this. And as soon as it's false, we will exit. Is this idea sort of clear here? When this is true, we keep running the code inside the while loop, whatever it may be, right? Like this bit. And as soon as it's false, we exit. Okay, awesome. Now, one thing I like to do is to just turn this into a diagram. And a good way to think about this diagram is sort of like how the computer will move through this code. Right, so definitely you can use a let, like usually the let will be this condition, right? And we'll go over some examples very shortly. So that's a good point. Why do we actually need to use a while loop? Why not always use a for loop? So the loop that we use depends on what we're trying to do. And depending on the problem, it might be different. So it'll be more clear when we actually cover the game later in the day, why we actually could not do this using a while loop, or why it would be, why we couldn't do it using a while loop. So actually, I can even give you an example of why we might not want to do that. So, maybe we only have something running as long as the user wants it to run. So we could make a program where, and I'll actually do this here. Let's just say this is our condition. This is our condition. And then we run some code here. If the condition's true, we run some code here. And then we go back to the start and we ask again this condition. Is it true or false? If it's false, we exit. So what if what we're doing is we want to print something as long as the user wants to print it? Exactly. It's when we don't know the number, right? So maybe like the user has to say, the user needs to be asked if they want to keep printing it. And maybe, that would actually be here. So the user is asked, do you want to keep printing something? So all that's happening in the code, let's say, is just a console log. It just prints something to console. And then the user's asked, do you want to continue? And if they say yes, then this condition remains true. And they do it, and it happens again, and it keeps happening, and so on until the user says no. When the user says no, this condition becomes false. So the next time we go through this, it's false, and then we exit. And I can also quickly code up an example of this as well. So let's actually pull up our VS Code terminal, and let's just see some examples of this. The terminal does accept yes as an answer, and we'll go through that. So let's first just do a standard while loop. So let's just say while. I remember someone mentioning something about variables, so I think that's good. Let's start, x as 0, and let's say while x is less than 2, we're going to do something here. Let's just say, let's print x is less than 2, and then we will update x, because if we don't update it, if we don't change anything, then this will keep running permanently. And we will say x has been updated to, and then just refer to the x that we have here. So the idea here is that we enter this loop, x is 0. When we enter this loop and x is 0, 0 is less than 2, that's true. So we print this statement, x is less than 2. We update x to 1 because we're saying x equals x plus 1. Once that update happens, we're going to print this to console, and this is going to say x has been updated to 1. And then we go back to the condition we check. Is 1 less than 2? Yes. So we say x is less than 2. X equals x plus 1. X was already 1, so now x equals 2. We set the value of x to 2, and we print x has been updated to 2. Now we go here again. Is 2 less than 2? No. So we just stop. Let's run that just to see. Right, so we don't need while, but I'm going to give an example where we will. So here we don't actually need while, right? Let's say here's an example. Here's an example where we will need while. And what I'm going to do, I'm actually going to, because I need this library. Because we're going to do an example with user input. Let's say our keep running. This is going to be our condition for whether or not we enter the while loop. Okay. While that's true, we have entered the while loop. Now I'm going to ask the user here, user input. I'm going to say, do you want to keep, you want to stay in the while loop? Or rather, I think that would be, yeah, that's going to be yes or no. Yeah, this is a good example. So if the user wants to, this is one example for when we might use a while loop. There are a lot of other cases. It does depend on the problem at hand. There are certain cases where it's easier to do something using a while loop than a for loop. We'll get into that later as well. Yep, Samra has a question.
And so, yes, so have you completed the code or is there anything left on in this particular example? So, for example, you are asking user input, do you want to stay in the while loop? Based on yes or no, how will it correlate with keep running is equal to true?
So I haven't finished writing this code. No.
Okay, perfect. Yeah, okay, got it.
So we're going to take the user input. Let's assume the user always writes like yes or no. Although, you know what? All right. So if user input, we're going to say if it's yes, let's just use a double equals just to make things a little bit simpler. Else, say anything else that they type, it just kicks them out of the loop. So no, it won't be yes. It'll be true because so this has to be true, right? Because remember, this is a condition. A condition has to evaluate to true or false. So this is like we're telling the computer how to do something. It's not like how we would think of how to do something. Yeah, exactly. But so if we put in yes, what should we do here? Or should we do anything? Break? Not quite. Because if we want to stay in the while loop, what happens if we put a break here? For sure, we could put continue, actually. That's a good point. So actually, I think I will adjust this to make it a little bit easier. If user input, based on what we see here, does not equal yes, I think that'll be more straightforward. What should we do here? And I don't want to use break. So how can we get out of this loop without using break? It has something to do with this keep running. Exactly. So we set keep running to false. Let's work through this. So we set keep running to false. Now, why does this work? Feel free to share in the chat. Why would this work? And I will actually bring up this right here. Yep, the condition is false. So we do break out of the loop. But we don't break out of it in the same way that we put a break statement, right? We break out of it because we run the code. Here, this is where we are at line 18, right? We check if user input is not yes. If that's true, the user input is anything other than yes. We set keep running to false, and then we go again and check the condition. The condition is based on the truth of keep running, if keep running is true. But we've set it here to false. And because this is false, then we exit out of the loop. It's different than using a break statement. Okay. Let's run this and let's see what's going on. Let's see if there are any bugs or if it runs perfectly. Let's say I just write X. Okay, perfect. That does not run. Yes. Yes. Right, so as long as I type in yes, it continues. So that's an example of why we might want to use a while loop instead of a for loop. Yep, Sawa, I see you have a question.
Yes, Salim, thank you so much for this. It's clearing things up for me. So I was wondering if you can explain the difference between using a break statement as opposed to changing the value of the variable to false. Is that like just two options that we have, or there's a difference between when we would do each? So instead of using the break statement that we learned yesterday, and then or changing the variable to false, what's the difference between the two?
Sure, yeah, no worries. One difference could be that if we put a break like here, we would not execute anything else. So let's actually change this. Let's make this a break. Actually, first, I'm going to keep this as false. I'm going to console log something here. I'm going to say hello, and let's see what happens. And I'm going to say no, right? So it will set keep running to false, and it still prints hello. But if I put a break here, I hope this is right. I put a break here. No, it immediately exits. There's a whole bunch of other code here that could be run that is not run if we put a break. So that's one example of using it, right? Yeah. So I think, preferring to use one or the other would depend on the circumstance and what we want to program.
Okay, thank you.
So I see Samra has a question.
Yeah. So what if user input is yes? So in that case, you have just left empty brackets. So what does that mean? So yeah, do we not give that if user input is yes, keep running is equal to true? We don't say that, or empty brackets means that it will be true.
So the empty, do you mean like these, like why I don't have an else, why I just have a check for if user input is not yes?
No, no. First, get rid. We don't need the break statement, right? So we can get rid of the break here.
Yeah. So there are two ways of doing it, and the difference between them is that if you use a break here, you will not print this
I understand.
console
I
log.
understand that. So my question was that in the previous line when you were okay. So I'm not sure why I cannot see that if user input. Okay. So what gonna happen? Okay. So you are just giving me this one if condition that if it is yes, if it is not yes, then it should say that then it should break, and that's why it will be, and all other conditions it will go to keep running is equal to true.
Yeah, exactly. Yeah. So if I put keep running true, it just sets this thing to, or rather, sorry, if I put this as false, it sets this to false, and then it'll exit this if here, and it'll keep executing all the code until we're at the end of the while loop, and then when it goes back and starts again, it's like, oh, keep running is false, so we exit the loop.
Okay, got it. Thank you so much.
Yeah, no worries. All right. Use breaks. Right. For sure. I think when we get more into the individual question bit, I think once we solidify some of these concepts, then we can take a look at that and see what's wrong there. All right. So is this while loop clear for everyone? And also this distinction between break and using break and then actually modifying this condition directly? Oh, good point. All right, yeah, let's see what happens if I put hello out of the loop. And I keep the break. Let's keep the break as well. Let's see what happens. What do you actually, Roman, what do you think will happen if I put my hello outside here with the break in this?
Well, it's supposed to be print hello because it's just another code which will run.
Exactly. I put no or really anything other than yes, breaks, and it runs. That's correct. All right. Now that that's clear, let's check this. Oh, Samra. I see you have your hand raised. How can I help?
I'm sorry, I'm just lowering it down.
Oh, okay. All right. Exactly, yeah. So break skips to statements after it within the while loop. It's like looking here, it's like, okay, break Let's find the loop and then let's exit out of it. Exactly. So there's one thing I want to check. Okay. For sure. I think we can definitely use a break in a for loop. Let's test that out. So what I will do, I will comment this out actually, so we don't need to run that. I will uncomment it when we get back to it. So yeah, let's use a break in a for loop. Let's say I is 0 and we run until 4. And let's say we're just going to be printing numbers. Let's see what happens if we put a break here. So let's say if I equals 1, oops, double equals. Oh, sure. Here, so I'll just make the screen full size for now because we're not really looking at those slides. How's that? All right. So what do people think will happen here? And let's even do this. Our number is I. What's gonna print a console when this program runs? Like, yeah, it is gonna print 0, but it's gonna say our number is 0, right? Okay, good. Interesting. But actually, it's gonna print 1 as well, right? Because we will still enter the loop with 1, right? And then it's gonna print that. Now, how would I actually change this to not do that? Let's say I only want 0. How would I change? Where can I put this console log to only have it print our number is 0 and not have it print our number is 1 as well? No, if I actually, yeah, that's a good, that would work as well. So if I put I equals 0 here, good point. It'll work. It'll definitely work. Now it only prints 0, right? But what if I keep this as 1? If I keep that as 1, where can I move this console log so it only prints our number is 0 and it doesn't print our number is 1 as well without changing anything else, just moving where this console log is. And the console log will stay inside of the for loop. Exactly. I can move it after the break. Yep. I move it right there. Now when I go through this program, I'm like, okay, I start at 0. Yep, 0 does not equal 1, so I'm not going to enter this. I'm not going to break. And then I'm going to print out our number is 0. The next iteration, I is 1, but I does equal 1 here. So then we do break. And let's just double check that. Yep, our number is 0. All right. Yeah, that is an example where we can use breaks and for loops. All right, let's proceed to the next example, and I will actually make this bigger as well. So there's something else to talk about, and there is, yes, Awa?
Yeah, sorry, Alim. I was noticing there's a bit of a difference between the while loop and for loop. With the for loop, the let statement is within the bracket, and then with the while loop, you have let outside. So I was just wondering, like, would you be able to explain the difference in that? I don't know if I'm
You mean
being
the
clear.
condition to check that it's still running?
Yeah, exactly. So
Oh,
with
okay,
the
yeah.
while one, you have let keep running equals true, whereas with the for, the let is inside.
Yeah, that is just sort of the syntax as well as the sort of how I've written it. Let's actually see if we can make the while or for loop look a little bit more like the while loop.
I think it's because in the for loop, you have to assign the value, the starting value, whereas in the while loop, we can assign the starting value before.
Mhm.
When you're assigning the starting value in the for loop, you're actually kind of declaring it over there. Whereas if you declare it in a while loop, you'll have to assign it. I think that's my understanding of it.
Thank you, Samina.
Welcome.
This is just a test. I haven't actually done this before. Like I haven't tried to make the for loops look like a while loop. So this could not, maybe this doesn't work, but I'm just going to try this. So I'm actually going to set I to be equal to 0 up here outside. And then I'll just reference I here in this syntax where, instead of declaring it here, I will actually just refer it. And then I'm going to do what I did in the while loop, and I'm going to move the condition outside to I is less than 5. So that's also why I declare it here, I is 0, because I want, if I only move the condition outside and just have the I be declared inside, I would get an issue with the variable is being referenced before I've declared. So I'm just going to move I outside here, have the condition here, I is less than 5, and let's see if this still runs and we get the same. We should hopefully get the same output, that our number is 0, and then just have the loop stop. So let's see if that works. Perfect, that does work. So here I make it look a lot more like the while loop. And even, let's even try to make it look more like that. So let me get rid of that. Oops. And maybe that's okay, maybe it actually does not. Oh, interesting. Okay. Let's try this. Let's update I here, right? Technically it is updating at the end of the for loop, but let's move it inside and have I update there. Perfect. It still works. So this is just like, I've kind of modified the loop a bit, the for loop, to look more like the while loop. And maybe, I don't know, maybe I can even do that. Maybe not though. Yeah, so I don't think I can modify it that much. But yeah. All right. Yeah, I was seeing that there was like, it says it's expecting that, which probably means, that's interesting. I don't think this will run though, because I think it's going to interpret, oh wow, so that actually does run. That is interesting. So yeah, now we've really gone quite a ways to making that look like a while loop. Yeah, I've never actually done this sort of modification before, but this is interesting. Definitely going to look into this. All right. So now, with that out of the way, let's go to the do while loop. So do while is actually very similar to while, but there's one key difference. Interesting. Tells the function won't execute if the break. Kind of blurring out. Oh, let's see. That is actually pretty neat. Yeah, let's try that. Let's say, I've seen it might not do it in this one, but I have worked in other programming like environments where that is done, where it does sort of, the rest of this does blur out. And maybe let's just put true here actually, because it's not going to depend on user input. Okay, there we go, right? So that's a good thing to know. The compiler will tell you here that we have unreachable code detected. And then even, let's see, yeah, it just tells us to remove it. Right, because if I say this is true, it's always going to be true, and we're always going to be breaking out of our loop at this point in time. So this code is never going to run, and that's why we get this message here, unreachable code detected. All right, let's undo those changes. Talk about do while loops. All right. So the standard, it's very similar to the while loop. So, but instead, we're going to first check, essentially, we're going to first run the code and then check the condition. So we're going to do some stuff. Yeah, Notepad is, that's why it's definitely good to use like a development environment where you can get feedback on syntax errors. So this is what the do while loop looks like. It's a bit different than the while loop. Let me just double check that diagram. Okay. And the main difference is that as we enter, we're going to execute this first stuff. And then we check our condition. And then if the condition's true, we repeat. If false, we exit. I'm just going to double check if I have that diagram down right. Yeah, perfect. So does everyone have sort of this idea clear that we first are going to execute this and then we check our condition? So the do while loop will run exactly the conditions coming after the code, so that this like stuff that we run will run at least once, whereas the while loop is not guaranteed to run at least once. And so I can actually show you an example. Yep. So in this while loop, the syntax is sort of like this. We have do, and then we have our curly braces and stuff, and then we have our while condition after this. And the diagram looks like this. So we will enter our code block, we will run some stuff, and then we check if our condition for remaining in the while loop is true or false. If that condition's true, we go back and we start again. If it's false, we exit. So the do while loop runs the code at least once. And I will pull up an example, and I will compare while and do while in an example, just to make things a bit clearer. Let's first write out our while. So let's just say x is 0, and we're going to say while x does not equal 0. I'm going to print out hello. Let's just use double. Okay. What is this going to print? What is this while loop going to print? Exactly, nothing. No, it doesn't print false, right? Because false is a very specific, unless if you mean false, it will not print. Okay, yeah, so yes, it will not print anything. Right, it doesn't print anything. But now let's try this. Let's change this while loop to a do while. I'm just going to comment that out, and let's try this. Do what's this going to print? So this thing stands for not. So if I write not equal, I'm essentially saying x does not equal 0. Exactly. So it's going to print hello. Okay. Try that out. Yeah. And it only prints hello once, right? Because so I did see someone here mention an infinite loop. So the reason why it doesn't print an infinite loop is because this while condition will actually be false. Right? This 0 does not equal 0 is false. So it can't, no matter what, it cannot stay in the loop. Yeah. Okay, awesome. All right, perfect. Oh, it says I am signed in on another device. Wait one sec. One sec, I'm just gonna ask my team. Can everyone still hear me? I think as long as I don't click this OK message, it will not sign me out. Okay, so everyone can hear me, right? Okay, good. Because I just don't want to be signed out. Okay. All right, so I think so. Yeah, before we get to like more practice, I'm just curious. Does anyone have any questions about anything we've covered in lecture? Data types, if statements, uh, if else statements, any of the logical operators like and, or, not, or any like conditions in general, evaluating conditions. Sort of any questions about lecture material that these concepts that we've covered. Don't worry, I'll give it like a minute or two because I do know like if I'm asked if I have any questions about these concepts, I might need to think it for a little bit for sure. All right, so let's repeat logical operators. Okay, yeah, let's talk about logical operators. Oops. So before we get to there, okay. So logical operators that we are worrying about right now have and, we have or, and we have not. I'm going to use so these are all logical operators that we're going to work with, and I will actually just write the syntax right below it in yellow. So we have and is like the two, I think these are called ampersands, these like and symbol. We have or, exactly, and we have not. So not is the exclamation mark. Perfect. Now, instead of writing logical operators, I'm just going to write OP for operator when I write like the abstract syntax up here. So generally, these logical operators work in the form of, you can have some condition or some variable. It can be a condition, it can be a variable, condition or variable, and you will have condition, variable, so on. So that's like a very sort of abstract format of how this would look in an expression. You could even have, like I think we've mentioned here, you can have something like not true. So not be thought of as a bit of a special case, because that is more of the form of like having our operator, and then we just have either our condition or our variable. So I say condition because we can almost think of like when we have multiple, like a variable and then an operator and then another variable here, we can say like this whole thing is a condition, right? And the reason why I put it in that format is like, we can also outside of this, just have another operator, maybe a not operator, maybe an and operator, and then we have another condition here. So I know that was kind of abstract. Let's look at some examples. I will actually bring up the code here so we can work through a few examples of what this might look like. So let's say my fruit is an apple and my number is 4. So I want to see what, and I'm going to console log this out. Actually, I will say my expression is going to be fruit equals number, right? So this is one variable reference, fruit, and another one, number. And I want to see, are these equal? So what's going to happen here? I'll actually work through the first example with everyone. Our computer will see fruit, we're going to put apple, and we'll see number, which we put 4. Exactly. Exactly, yeah. This is, they must be the same. Apple equal 4? No, it's false. And that false, remember, that's the Boolean type false that's returned. And then false is assigned to the variable expression. And so if I console log this expression, we get false. Okay, let's work through an example. Let's get another example going, and I will give you all this example to do. So let's see. That condition 1 is going to be number. It's going to be the same one. Condition 2 is going to be apple less than mango. Just changing these around, these names. So what is the expression going to evaluate to? Now I am using OR. So these are, I mean, this, yeah, so here, okay, so now I'm using OR here, yeah. So this was just an intro to, I just wanted to like review the idea of Boolean, yeah, no worries. And actually, okay, no, that's fine. So yeah, what is expression going to evaluate to? So I see here, Najla, what do you mean by either one will be fine? Either apple or, sorry, I don't understand. Yeah, feel free to unmute yourself and just like let me know what you mean by that.
So fruit, apple, number 4. So if the condition 1, fruit must be the same as number, right? So it has to be apple or 4. Condition 2, apple. Apple is not bigger than mango. So that's true. Because A comes first, then M.
Yes, so this is true. This evaluates to true, and then we get true assigned to condition 2.
So the
And
last
then,
line, so the 57, condition 1 or condition 2. So either one is fine. No?
So I guess, okay, what you mean by either one fine, do you mean like as long as one is true, then when we're using an or, then the whole expression's true?
Yes, either the condition 1 or condition 2, they are both correct.
Okay, yeah. So, yes. Because it's false or true, then our expression evaluates to true. Yes, false or true is equal to true. What is variable of number? Okay, so the number, this number, I'm saying it's going to be let. Let is the keyword I'm going to use to declare this variable number. And what that means is that, you know, when I give it let, it means that I can reassign number. It's not a constant, yeah. Okay, perfect. Is everyone okay with the conditions so far? Maybe let's do a bigger example. So let's say let condition 3 equal oops. All right, this will be a little bit of a longer one, but I think you guys can do this. And just remember, when you evaluate these, evaluate what is in the brackets first before sort of moving out of the brackets. Because I can remove these brackets that aren't really needed. All right, so I see some people have true, some people have false. That's okay. Let's work through this step by step. Actually, I have no idea what it is, so because I was not working on this, but that's fine. So condition 1 and condition 2. Remember, condition 1, let's actually just write these out here. It's a bit easier to reference to these. Right, condition 1 is false. That's good. Condition 2 is true because, you know, the A comes before the M. What about condition 3? So condition 3, oh, yes, condition 3 is true. Awesome. And it's true because this like double equals is a lot less strict than, you know, what we're thinking of it equals, because it knows that this string 4 is essentially going to be converted into the number 4. And so that'll be considered the same. What about the triple equals? for triple equals string 4. Yep, awesome, false. All right, so let's now do these. So condition 1, we know that's false. False and condition 2 is true. So we have that. And then we have, let me get the brackets right when I do this. So we have false and true, or something else there. Okay, let's figure this one out. Let's think, okay, so condition 3 is true. So we have true, true, and false. Condition 3 is true. Sorry, condition 2 is true, my bad. Condition 2 is true. And then condition 4 is false. That's the next step of this. False and true. False. True and true is true. False or true. Right? Yeah, I think everybody is sort of gotten this because right, because we'll have true and false, and then that's just false. Awesome. Let us double check that just in case. It's always good to be 100% certain that we didn't make the errors. Perfect. That's false. All right. Awesome. So I hope that was a clarified things on the in terms of logical operators. Does anyone have any questions about that or about any of these other topics? No. Here. Okay, awesome. So I want to briefly discuss functions because some of these extra exercises that we're doing they're going to involve functions very like sort of indirectly. So just so you know what it is, when you see that on the code, it's not like confusing at all. So the idea of a function or else if for sure. So, okay, I will very briefly go over when to use if else versus else if. So while and do while. Okay, for sure. So first we're going to explain the if else and then else if, and then I'll cover the while and do while. So if else is essentially when we have if, we have a condition here, right? And then we have else. So this is the true block. So if the condition's true, we execute the true block. If the condition's false, we will go into the else block and execute that code. Is that clear? This sort of idea? So, okay, perfect. So now let's go over else if. So, one downside of using this is that we can only really check one condition at a time, right? Because what if I want to check multiple things? If I have more if else's, I would need to put them inside this false block. And I can show you an example of that. So let's say here, let's do that here. Let number equal 3. And let's say if, oh, I think I defined it already up here. Okay, so just comment out. Okay. So let's say if number is 2, your number is 2, else, like, what if I want to still check if my number is like, if I want to check if my number is 10 and have some like special behavior then, right? So would need to put another check here. The number is 10, right? Because we only enter, so true case is only, so I'll actually put it here. We only enter this case, number is 2. we enter the else block if number is anything other than 2. And then again, we enter this case is 10. And then here we enter it if number is anything other than 10. So we're only able to check one condition at a time. And it becomes very tedious. If we want to start having like very special behavior for different numbers, we would have to keep nesting these, and it makes it like very messy and difficult to read. So let's see a different way we can do this. So one way we can do this is we have the else if. So this is when we can check multiple conditions at the same time. Well, not at the same time, but I think one way to think about it is that we are chaining these ifs together. I'm just going to put C2 here. Yeah, I'll show exactly what the structure looks like. So as you can see here, if this condition is true, we enter that true block. Else if C2 is true, we enter this one. C3 is true, we do this one, and so on. And we can have another else there, so I will actually implement this just to see. So if number equals 2, we do something. Let's say hello, right? Else if number is 10, abracadabra. Else if number is 3, focus. We don't need an else here, but we could put one. We could put another else here. So if we don't put an else here, our code will stop executing. If our number is neither 2 nor 10 nor 3. If we put an else here, then we will enter this else block if our number is neither 2 nor 10 nor 3, because all these will be false, and we will be caught by this block here. Yeah, that's a good question. Like, just comparing these two and seeing, why might it be better to write it this way? Yeah. All right, so I'll comment that out. And let's briefly talk about functions. So in some of the practice exercises that we will be doing shortly, the reason why I'm talking about functions is because functions will be very indirectly, like you'll see the keyword function on the screen. So that's why I thought I'd just introduce this, although next week we will get into functions in more depth and really explain why we use these and where we use these and how it makes our job of coding a lot easier. So one way of thinking of functions is like a box. Something happens inside. I have an input and I have an output. Now in the examples we'll be doing, we can almost think of functions as like the code that we are writing, whatever that code may be, right? And input can be things like the variables that we have talked about previously. And if we put a variable as an input into a function, we can refer to and use that variable within the code inside. I guess that's the simplest way to put it. And then, yeah, then there might be something like a return statement. So if I say return 2 at the end, and let's say our code actually gets to that point, we will return the value 2 when the function exits. So the output, let's say the output could be 2, the output could be a variable, the output can be many things. But I think thinking in this way of input and outputs is a good way to encapsulate this idea of the function. And that in the examples we'll be looking at, we will have variables as input, and there's a specific term we use when we are dealing with variables as inputs into a function, we call them parameters. All right, does anyone have any questions about that? You won't be writing functions anytime soon, but I thought I would just introduce this idea of function just so it doesn't look too confusing when these examples come up. Yeah, so we'll get into that more, but in the context of this, we're just going to think about variables as inputs to function, as inputs to functions. Okay, is everyone clear on that? Just please do like type yes in the chat so I can see that. All right. So I think before we continue, let's take a 10-minute break because we've had lecture for like a solid hour. So yeah, let's go on 10-minute break and we'll come back at 9:20 and then we'll actually go through some more examples just to solidify everything we've done this week. So I'm just going to share my screen. Can everyone see my screen? Okay, awesome. Okay, so as you can see, I have this like free code camp open, and I thought we may as well go through a few of these few questions here. And the reason why I want to introduce this resource is because it is a very good resource for doing practice questions, maybe finding, you know, more explanations on concepts, and you know, these exercises are even like you can do these in real time and then run the test and get the output in real time, like you know, whether your code is correct or not. So you can get immediate feedback. Absolutely. Yeah, this is awesome. I remember using this not too long ago when I was learning JavaScript. So for sure, yeah, I think now usually, of course, it's not like an online dev environment because it's not like you can, or maybe it is, maybe somewhere there is that option, but at least here, you can't really write your own code and compile that. It might give you your output, but this this snippet here that you write is very, very specific to each of these exercises. And so you see this like run the tests. So this will tell you if your code is right or not. So yeah, let's try this. So we have this function. So again, I remember I very briefly introduced functions, so don't worry about it too much. But the idea behind this is just that this is the variable that we need to think about in this code. And it even tells us only change code below this line, only change code above this line. So let's actually do that. Okay. So what this question is telling us to do is to, there are some hints. Yeah, it does give hints as well. I think it should say right here. Okay. So we want to create an if statement inside the function to return, yes, that was true, if the parameter was that true is true, and return, no, that was false, otherwise. So let's work through this together. So what should I start with? Okay, I'll start with an if, right? So what should I put inside? So I don't need to assign a variable, remember, because I am getting a variable here or a parameter so this is the one that we need to think about. And so we make an if statement, and inside this function, we have a console log. Yes, that was true. if this parameter is true. Otherwise, we log this to terminal. So what should I put here inside these braces to check if it's true? No, I don't put true. True is going to be true, right? It's going to evaluate to true. What do I need to put there to have this conditional behavior that we want here? What do I need to check is true? Exactly, if was that true? Okay, here, wait, I see someone for sure. I have posted a link to this, so if you want, you can work alongside and just and run this as well, for sure. Exactly. Was that true? Now, we don't even need, I mean, we could do this, but we don't actually need to. Because was that true will be true or false itself. All right. We have an if and an else, right? Because we want multiple behavior. So what should we write over here in the true block of our if statement? So what should we put here? Remember, I want to return, yes, that was true in this block. So I'll give a hint. It's not going to be a console log, but that is very close. You're right. I probably should have mentioned this. We want to return a string. We want to return, yes, that was true. And I think even it says here, yeah, it says here, should return a string if this is the input, should return a string if that's the input. And in fact, we want to return this string here. So these are just tests that it's going to run. Yeah, I should have mentioned that. So because this is a bit different, we're returning a string. We're not actually we're not actually going to just console log something. Exactly. So we return, yes, that was true. And then here, we'll do return, no, that was false. Awesome. Let's run this. Let's see what happens. Perfect. So how's that? Does everyone sort of get why this is working? Awesome. Let's run that. And let's go to the next challenge. We'll do a couple of these because I think these are really good to work through. So in this case, I guess we can skip the explanation because I'll explain the if there are any issues with that, I don't mind, I can explain that. But we want to add an equality operator to the indicated lines. We want to change this line, just line 3, so that the function will return a string equal when val is equivalent to 12. So essentially, we want this condition to evaluate to true if this equals 12, because we're returning that. So how can we change this line to make that happen? I'm gonna wait. A few people have the right answer, yeah, for sure. So exactly, I'm gonna do that. Val equals 12, double equals 12. Run that, perfect. So how does everyone feel so far about this this free code camp? Absolutely. It would also work for a triple equals. Yep. Awesome. Yeah. Okay, so now you're going to see the difference between strict and sort of not strict. So because now we want to use the strict equality operator here. We want to change this line so that the function returns equal when it's strictly equal to 7. So it's very similar. It's just like we just want to do that. And I think if we check this, these are the tests that are being run. This is how it knows that we have put 3 rather than 2 equals. And the reason why that's happening is that if we run this function and we pass in the string 7, which would mean the val is the string 7, not the number 7, we want to return not equal. And that will only work if we use a triple equals. Because remember, the double equals, like if we were to do 7 equal 7, that is true. So if this was a double equals, we would actually return equal. And let's try that out right now, just so we know that the tests are working. Right here, it says, even if you make errors here, one thing I like about this is that the feedback is actually quite readable. Test strict, this string 7, which is this val, that's what we're passing in to be val, should return the string not equal, because we're returning equal, and it even tells us you should use the triple equal operator. Let's make that triple equal. Let's run that. Perfect, that works. So this is going to be pretty similar. So this compare equality function, we take in two parameters, A and B. Now these can be numbers or strings, is at least what I'm noticing here. We want to modify this line so that it returns a string equal only when the values are strictly equal. And I will explain here the difference. 10, and this 10, these are not strictly equal. But with this double equals, it's going to return true. It's going to return equal. So how can I change this line to make sure that if I were to pass in 10 and then the string 10, I get not equal? Awesome, triple equals. Perfect. Okay, so in this case, I want to use an inequality operator in my if statement so that the function will return the string not equal when val is not equal to 99. So how would I change this to do that, to accomplish that? Remember, so I want to return not equal when this is 99. Exactly, so we can just put not equal 99. Perfect. On that. Let's see what we get. Awesome, so we got that right. All right, let's try this one. We'll just do a few more and then I think we'll take a very short break and then we can move on to the main feature of the lecture, which is going to be making a rock, paper, scissors game. So yeah, let's just do a few more of these. So here we want to add the strict inequality operator. Remember, the strict equality is triple equals. And then but now it's strict inequality to the if statement so that the function returns a string not equal when val is not strictly equal to 17. So how would we change this to do that? Exactly. So we would put not 17. For sure. Let's see. So let me explain the difference between double equals and triple equals. So the difference between double equals and triple equals is that the double equals is a less strict equality comparison. So if I were to do this, 6 double equal the string 6, this would be true. Whereas if I were to do triple equals, this would be false. So that's a comparison of these two operators and how they are different in terms of their strictness. Does that clarify the difference between these two things? Okay. Not sure. Okay. Yeah, feel free to unmute yourself and just yeah, let me know what you're unsure about. Yeah, so notice how one of these is a number. This is a string. When you have the double equals, JavaScript is pretty smart. What it will do is it will actually try to convert this to the same type, to a number. And it's like, okay, the string number, I can convert that to 6, the number, very easily. So I'm going to say these are actually the same. These are equal, and then I'll return true when I compare these two. Whereas the triple equals does not have that in there. Triple equals is a bit stricter. So it will return false on this comparison. All right, awesome. Run that, perfect. Okay, I will let you guys read this because it's not actually that much. So this is just a really quick explanation, but this is what we need to do. So I will ask you later. I'll just see in the chat. So what changes we should make. So to let me know in the chat, just put the line number and then how you would change it. So these two lines need to be changed with the greater than to make this to make these return statements make sense. So do put the line number that you would change as well. So like line number 2 and then what you're changing. So I know it's not because there are two things that need to be changed, line number 2 and line number 6. Awesome. Awesome. This looks great. So we're going to first put val is greater than 100, and then we're going to put val is greater than 10. Let's see if that works. I'd say it should work. Perfect. All right, let's try this one. Okay, so we'll do the same thing here. We're going to add the greater than or equal to operator to the indicated lines so that the return statements make sense, and it'll be the same process as last time. So, write the line and then how you would change it to make this make sense. Perfect. Perfect. Does everyone does anyone have any questions so far, or is this clear? Awesome. Yeah, this is a great resource for practicing. All right, let's try this one again. Yeah. Very similar process. Just let me know the line and how you're going to change it. Remember, this one is, yeah, this one's less than, perfect. Less than 25. And then this one, less than perfect. All right, awesome. Oh, what's going on here? Ask me later. How about this one? What about this one? Less than or equal to 24. Perfect. Great. All right, this will be a little bit more involved, but what it wants us to do is replace the two if statements with one statement using the and operator. So actually, I think what we should do before we get to this one is it's 9:40. Let's take a 5-minute break, and then we'll go through a few more of these. So we still have, these are just going to solidify the logical operators. And then I think we're good to actually go over the example that we're going to cover for the rest of this class, which is making that rock, paper, scissors game. So let's take 5 minutes and then we can come back. Awesome. So I'll be back at 9:48. So yeah, I think this is actually a really good question because it's just going to show us how we can use the AND operator to simplify something. So notice how here we have if num is greater than 5. So if this is true, we're also going to check if our number is less than 10. So it's checking that our number is larger than 5 and less than 10. So like 6, 7, 8, 9. And if both of those are true, then we return yes. Otherwise, we return no if either of those are not true. And so we can change it to look like this, to just have one if statement. So this is a really good example of an and operator being used to simplify the code that we have. So we don't really need this nesting structure. Oh, my bad. Sorry about that. Let me share that. Okay, can everyone see my screen now? Okay, awesome. So I was just mentioning that, you know, in this code here, we want to try to get a number that we want to return yes if a number is between 5 and 10. So the numbers 6, 7, 8, and 9. So to do that, if we're just going to use these ifs and very simple if conditional checks, then we have to do something like this, where we first check if our number is bigger than 5. If that's true, then we have another if statement that checks if our number is less than 10. And if that's also true, then we're going to return yes. Otherwise, if either of these are not true, we're eventually going to get to this line and we're going to return no. Whereas here, we have this logical operator. So we can just say if the number is greater than 5 and the number is less than 10, we return yes. Otherwise, we return no. This is one very good use case for a logical operator. It's to simplify our if statements, so we don't need these sort of less nesting operations. So looking at this, how might we change this? How might we replace the two if statements with just one if statement using the and operator? to return the string yes if val is less than or equal to 50 and greater than or equal to 25. So between 50 and 25, including 50 and 25, otherwise no. So I see someone has an answer. Awesome. Anyone have any ideas on how we would change this? Okay, I see some, yeah, I see some about changing our condition. Awesome. So let's actually do that. Let's comment that out. Let's change. So we're gonna do if val. I will put like that. And if that's true, we return yes. Right? So we said greater than or equal to 25 and less than or equal to 50. Perfect. Let's run that. Sweet. All right, so now we're going to look at the logical OR operator. Let us see. So here's a case where, we have, okay, if our number is greater than 10, we return no. If it's less than 5, we return no. If either of these are not true, we return yes. So for the numbers 6, 7, 8, and 9, we would return yes. Now in this case, to simplify that, they can just say, okay, is the number greater than 10 or is it less than 5? So over these, either of these are true, we return no. Otherwise, we return yes. So how might we change this to just have one if statement with an or? So we want to return the string outside if val is not between 10 and 20. Inclusive. Val is not between 10 and 20. So that, I believe that is including 10 and 20. So it cannot be 10 and it cannot be 20. I can just double check that in the tests side. Yeah, so interesting. Okay, so I see the use of a not. That's very good, right? Let's try that. Let's modify things a little bit. So we are going to say we're going to return outside if val is not between 10 and 20. Right. So I can see that if we're going to have, let's actually try that. I think that's a good, nice try. So even though we're not using an or, so what this is going to do, if I just have that, I will add the not there. So we can try it with a not, and then we can also try it with an or. This is saying that if our num is 10 or anything greater, I think you would actually need a, okay, so if our num is larger than 10 and also less than 20, including 10 and 20, we're going to return outside. So this guy says that we return the string outside if val is not between 10 and 20 inclusive. Okay, let's try that. Let's try to put a not outside of this. Oops. You have to do that. Well, this is actually val. Perfect. Let's see. I think it works, but it just wants us to use, yeah, so all the tests pass. It just wants us to use the OR operator. So what I can do is I can get rid of this. And then what I will do, this is a trick learned. I can put not, let me just see if this works properly. I don't need that. And then I can make this, should run. Okay. Now I will actually change this. So if I do a not on a greater than or equal to, I will get a less than. Same thing here. Would be the same as writing val less than 20. Wait. Less than or equal, sorry, that would be greater than 20. It's kind of like if we are outside this range from 10 to 20, including 10 and 20, we return outside. Okay. Does anyone have any questions about that? I guess they explain it a little bit strangely here, but the idea is that if we are outside the range from 10 to 20, including 10 and 20, so if we're 10, 9, 8, 7, 6, decreasing to 20, 21, and so on, increasing. If we're any of those numbers, we want to return outside. We only want the numbers 11, 12, and so on up to 19. Yeah, perfect. Okay. Let's see what comes next. If else statements. Okay, so I think everything, I will share this link again, and I think at your guys' leisure, feel free to go through those. It's really good practice. But for now, let's cover we're going to cover a specific topic. So we are going to talk about rock, paper, scissors. And we're going to, from scratch, code this rock, paper, scissors game. All right, so I guess I can first introduce this game. So rock, paper, scissors, it's pretty popular. I'd say all of you probably know it, but if you don't, that's okay. So we'll just talk about the rules really quickly. So this is a game that's often played. You have scissors, my best impression of scissors, and then never, oh, okay. So it might be like a North American thing, but it's a game we often play. So we have scissors, rock. Yeah. So you do it with your hands. You can make like scissors and then rock and paper with your hand. It's just a fun game to play. And then we have paper, right? And the idea behind this game is that I will actually draw arrows. So rock beats scissors. Scissors beats paper. And paper beats rock. So if you pick rock and the person you're playing with picks paper, they win. And if you wanted to win against paper, you'd have to pick scissors. And if they want to win against you and you've picked scissors, they would need to pick rock. Exactly. Yeah. So those are the actual symbols when you play the game. Those are like the little hand signs you make. Exactly. Exactly. Yeah. So that's the idea as well, for sure. Perfect. So let's actually talk about this game and think about how would we actually make a game like this. So I will introduce a few rules in this game that are specific to our code that we want to be able to happen. So one thing we want, I think, before we actually start planning is that we want this game to keep score. We'll go into more about how that happens when we actually do the planning. We want the game to keep score. want 5 rounds per game and want the option to keep playing. Yes or no. Let's think about how we might start this. Just in terms of, I think the best way to start this would actually be to draw a little bit of a diagram of how we're going to do this. So maybe somewhere here, we want our scores. I'm just going to draw that there. And, we can think of this in terms of initializing variables. I think that's a good way to think of it. We have our score, we have the computer score, and both of those start as 0 naturally. And maybe we also have some information about the round that we are on, right? So I would say, for sure, so we can have rock, paper, scissors as a string, but we might be able to do these checks inside, like the actual code, a little bit later. We'll go over this. So let's say we're going to enter this. And I think, yeah, one more important thing is we want a way to keep playing. So maybe we have so maybe not a for loop. So I'm thinking more of a while loop to keep asking. So remember when I had that example where I had that condition and it was like, do you want to continue? And if you hit yes, then it printed it. And if you hit no, it changed that variable to false. And that the while loop was using that variable to decide whether or not to continue, right? Okay, awesome. So maybe we have something we want to keep track of. Do you want to play? So let's say, I'll just call it play. And I'm putting this here because this is going to be, so we start and we check, does someone want to play? It's false. They don't want to play. We exit. If they do want to play, maybe that's where we want to have these scores and the round. We want to keep track of that. For sure, if we have a set number of rounds, so we could, we could also use a for loop, even if we don't have a set number of rounds. If that person tells us, we can even do that, and we can go into that later. Yeah, once I actually implemented, so I'm going to use while loops for both of them, but once that's done, I will actually show an implementation. I can do another implementation where we use for loops, at least for the second option, for how many rounds. Okay. So maybe our other condition. So we're also going to use a while loop here. And this while loop is going to check how many rounds we have, because presumably, do we still have, more than 0 rounds? And if we don't, we can exit. Otherwise, if it's true, we're going to have some code here that executes. We're going to keep executing. And I think, what would be even better than that is actually, remember, the false case for this, because this while loop for like checking what round we're on is still inside playing the game. So even if you exit this round, like even if the game ends, the rounds, 0 rounds left, we're still inside this play loop. And that'll be more clear when I actually write the code. So what we can do is we can have some other code that runs here. And this actually tells us the score. and like the final outcome of the game before exiting. All right. So what are some things that we need to think about here? So this is like the game itself. So what are some things that we would need to think about in terms of actually playing the game with the computer? Okay, I see user input, so I'm going to put user input. What we want to choose, rock, paper, scissors. So the previous lesson, I think it's already on YouTube, at least from yesterday. But once this lecture is done at noon, we will upload this lecture. But the lessons from yesterday are already on YouTube. Yeah. I see something about if conditions, right? Are you thinking about if conditions to like compare that? Okay, if I choose rock and the computer chooses scissors, I should be able to beat the computer. If else if, for sure. Yeah, so we definitely need if else if. And I would say actually before that, we need the computer input. I can see someone mentioned it. Now, what are some ways we can actually get the computer inputs? There's a library that we used before with a random number generator. Exactly, there's a random number. So we can use random number to get the computer like choice. Exactly. And how many options should the computer have to choose from? Yeah, 3 options. Exactly. So maybe we can even have it just generate a number, 0, 1, or 2. And each of these can be thought of as like an option, rock, paper, scissors for the computer side of it. And then we need to find, I guess, instead of writing if else, I'll just say who wins. Who wins that current round? And then we update our score. And I will put this in yellow. Here we need to, based on who wins, we update the score. That modifies a score. What's one more thing we need to update other than score so that we know, when to end this? Let's say if we only want 5 rounds. Good. So we need to reduce the round. Perfect. Exactly. So the sum of the computer and the user input. So I'm assuming you mean the score of the computer and the user, or okay, yeah. So we have that right here. This is scores. So that's something that we're updating. So this sort of, it may not like this here. This is this. These are the things that we're going to be updating as we proceed through this program. So these are all, this is good. So this is not like, this isn't the pseudocode, but this is, we will often, before making some program, it's always best to, you don't even need to write pseudocode. Even drawing something like this and like how you would proceed and what you need to think about is very helpful. So what I will do is I will put this on the side there. Let me actually zoom in. Oh, what's going on there? It's funny, if I zoom out, it actually gets larger, the screen. It's kind of funny. All right, so let's do this down here. Exactly, it's like a flow chart. Yeah. It is a flow chart, actually. This, like these, these like diamond-shaped conditions, this is, you could call this a programming flow chart. This is something that, we will certainly teach you as we are now, but this is also like just general part of curriculum. Usually even before programming, they'll often get you to draw these out. So I would say, if you really want to improve your ability to program, I'd say for every program you write, before you write it, for now, draw these out. True, false, especially when you have conditions. It's definitely useful. Maybe not for like the entire program if it's really complicated, but certainly in the beginning, for smaller programs, it's definitely useful. Okay, can everyone see how's the sizing of this like VS Code and this? Is the sizing okay? You can still see sort of what's on the slide. Okay, good. Let's call this, so this is going to be our rock, paper, scissors game. Okay. So one thing that we do need, we need to grab user input. So the first thing I'm going to do at the top is I'm just going to import this prompt library so we can grab the user input and like what they want, right? What's one more thing we can do? So certainly we can do a random number now, or we can maybe do, well, let's do the random number later when we're trying to find the computer choice. So I think what I'll do right now is I will just say let play equals true. And so I'm going to use this. Play represents if we want to play or not. And I will start it as true, just so we can like, the first time we'll play the game. Right, so I'm just defining play right there. Okay. Everything inside this while loop, this is user is playing the game. Everything inside this while loop everything inside of this is just going to be for, variables specific to the game. So what are some things that we need to think about? I remember I mentioned score, rounds. So what are some things that we can keep track of there? Not immediately. It won't immediately be conditions. It'll be actually be, and it won't be rock, paper, scissors either. Because remember, we can do that within each round. We will do that. Just going to remove that. So there are a few variables we can declare at the start here. We're not going to get the user input within play. Exactly, yeah. We can say we have 5 rounds. What's something else we want to keep track of? Even do that. So this play loop, this is not for like this play loop is not for this is for the game itself, including all the rounds. It's not for the specific round that we're playing. So that's why I actually have the rounds in here. Yeah, no worries. The one more thing we can think about here is our score. I haven't put it here. So what are the 2 scores we need to keep track of? Because we want to be able to say, how many points the computer got exactly. So user score and computer score. Now, what should I actually set these to? What does it make sense to set these to at the start? Exactly, 0. Awesome. All right. So now I'm actually going to do my while loop. I'm going to say while rounds left. Now, what's the condition to check here? Remember, every time you play a round, it's going to actually decrease by 1, the number of rounds. So what's a good check here? I have 5 rounds, and I want to stop when I have 0 rounds. Exactly, greater than 0. Yeah, because on the 0th round, I want to end, right? So perfect. Okay. So this is actually, so this is going to be this while loop. This is going to be the game itself. So this is going to be, now we're going to need to worry about scissors, about rock, scissors. Here we're going to have to worry about the user's input, computer input, what the computer chooses, and also who wins. So I will actually move this to another line. So that's all going to be here. What are some more things that actually should go here? Let's say once all our rounds are completed, what are some things that will go here? For sure. So exit will be one thing, but what tells us if we want to exit? Like, what if you want to rematch? What if you want to keep playing? Awesome. So I see the score. It's good. What's something else that we want to do? Remember, the user gets to decide if they want to keep playing or not. So what's something that we can do here? Exactly. So we can, do you want to play again? So we want to ask the user if they want to keep playing. If yes, we can just continue. We don't really need to do anything. Sure. Let's actually see. What about no? If no, I don't want to use break. I don't want to use break. What might I do here to avoid using break if the user does not want to keep playing? This is very similar to an earlier example. Exactly. So we can just set play false. Okay. All right. Does anyone have any questions about this so far? I know I haven't written much code, but I've just put comments in so that we can fill out the code later. Is this all right for everyone so far? This sort of, we have one while loop for playing the game itself, and we have another while loop to handle each round. Yeah, awesome. And it sort of makes sense. Like, we enter this game and we have 5 rounds, 0 and 0. And then we do, each round we'll play, right? The score will change. Computer inputs are found, right? And so play equals false goes here. Yeah. So this is the game itself. And once all rounds are over, we print the score and then we ask them if they want to keep playing. So if they do want to keep playing, we don't actually need to do anything. We just need to ask them if they don't want to play. Right? Because if they don't want to play, we'll set it to false. The loop ends and we go back up here and this is false, so we just exit. If they do want to play, we don't actually need to do anything because it'll still exit and then it'll come back and it'll check, is play true? Play is still true. And then here I'm initializing, again, we have 5 rounds and the score starts over again, 0 and 0. And it's a new game. Okay, awesome. Do we need other while loop to count the rounds? No, we do not. So I will actually, at the end here, I will write it here, update the round. At the end of the round, we're going to update the round. So the next time we go through, we have 1 less round. And so this will make sure that we will eventually reach 0 rounds. Yeah. Okay. Awesome. So let's actually make the game. So the first thing we're going to get exactly. So the first thing we're going to do is let's get user input. What am I going to do with that? How am I going to do that? what do I need to put the user input inside? Exactly. So I need prompt sync, but I also need something else to, yeah, we'll get to the winner. We'll get to the winner eventually, but exactly. So I see here in like a let user input. I'm actually going to use const because the user input does not change from round to round. It's only really going to be determined once, and that's it. So what's a good prompt I should put here for user input? Maybe like I'm just going to put choose rock, paper, or scissors. I'm going to do sort of do that just a little bit more. Paper or scissors, and what I will do. And there's something else I'm going to do. So it's not necessary. You can just make sure to write it exactly like that, or in lowercase. But what I'm actually going to do is I'm going to do 2 lowercase. So you don't need to worry too much about this right now. We can go over this in detail later. But what this does is it's going to change the string that you input into lowercase. So if you put in rock, right, in all capitals, it's going to change it to that. That just makes our job a little bit easier in terms of checking if the user put a rock in, right? Because we just need to check that. Is that clear? Yeah, so there might be some case sensitivity, right? So if I were to do, let me actually just double check this really quickly as well. There is some case sensitivity. If I were to do, are these people, I would actually get false because there's a different number like used to represent this lowercase than the capital. So yeah, if the user writes a capital, that's why I'm putting to lowercase. So no matter what they write, as long as they write rock, paper, scissors, they could even write it in a really weird way, like that or something. They could write like that. Like they could put some really weird input, but as long as it's like the correct word, this will turn that into all lowercase. Okay? You don't need to know like how this is used or like, why am I able to do a dot to lowercase? Like we'll go over that later, but yeah, so whatever they're going to write, it's going to make it that string completely lowercase. Exactly. All right. So from there, maybe we want to check that see if user input. I think for now, I can add this in after, but let's assume the input is correct. Rock, it's going to eventually be rock, paper, or scissors. Let's just make that assumption there. We can go into handling that later. It's not a condition put. So this just converts whatever they enter to lowercase. It's not a condition because they can still write, it in a different format, like with all caps. Yeah. Okay, awesome. So now let's try to think about try to figure out the computer's choice. So I remember someone here mentioned using the random number generator, and I think that's a great idea. So what we're going to do for that is we're going to get the random number first. And I'm going to do that. So again, what this is doing, math.random gets a decimal number between 0 and 1. 0.5, 0.762, 0.999. any decimal number between 0 and 1. And when I multiply that by 3, I get a decimal number between 0 and 3. 3 being the largest number I can get, right? Now, this floor is basically going to turn that into, so if I were to get like 2.96, the floor there is going to turn that into 2. If we were to get 1.33, it's going to be 1, and so on. It's kind of like round, but if I were to use round, 2.96 would become 3. So that's one difference between that. Yeah. Exactly. Is that idea sort of clear for everyone? Yeah, awesome. There's just one thing I do want to check with math.random is exclusive or inclusive. Okay, good. So there was one thing up because I don't want to get the number 3 because there are only, yes, so we can use the list, but I want to avoid using lists because we haven't actually covered that. So what I'm going to do is I'm just going to use this random number and I'm going to use a set of if statements to set the computer choice. Yeah, so this will ensure we will get random num will either be 0, 1, or 2. The 3 choices, right? Rock, paper, scissors. All right, erase this. And let us set the computer's choice to rock, paper, or scissors. All right, so I think a good way to do this is that we're going to use a set of if-else if statements. So what's one check I can do here? So remember, I'm going to start with a random number. Now I'm going to check if it's equal to something. So what's one thing I can check here? What is my random number equal to? Yeah, I can check 1. I can check 2. So I think just for the, so not 1, 2, 3. It won't be 1, 2, 3. Because this random number that I generate is either 0, 1, or 2. Exactly, yeah. Because remember, this is between 0 and 1. When I multiply that by 3, I get a number between 0 and 3, not including 3. But when I floor it, I cannot actually get anything that's 3. I can only get 0, 1, or 2. Exactly, yeah. I'm just going to start with the smallest number. So I'm going to say that computer, oh, there's one thing I'm missing. What's one thing I'm actually missing here? What is one thing I'm missing here? So I have the random number. No, I have the user input. There's something to do with the computer that I'm missing. Because the random number I get is different from rock, paper, and scissors. Exactly. So I'm missing the computer's choice or the computer's input. Yeah. I will say computer choice. And I'm not actually going to set it to something. I'm just going to leave it like that. I'm just going to declare it. I'm not going to initialize it. So here I would say computer choice. Let's make that rock 0. Okay. Now, how can I check the other 2? What sort of, how might I proceed with this to check number 1 and 2 easily? Awesome, Elsa. Perfect. Okay. So what should I put here for random number to check? Awesome, yeah. Let's try that. Random number is 1. And then, yeah, what do you guys want the computer to choose if the random number is 1? Other than rock. Okay, paper. Let's do that. Paper. And then here, obviously we're only left with one choice, so that's scissors. Perfect. And let's even tell the user, let's say that computer chose, let's even say, we're just going to also print the computer choice. So when we play this game, it'll say, the computer chose this. And, even I think what I want to do is that I want to put this in. I want to do that. I wanted to say you chose something and then the computer chose. This is some feedback choices. Okay. And then now I guess now we need to decide who wins, right? So what are some scenarios? Let's actually start the first scenario, and I think the easiest one. And I will actually make the structure of this. And what I will do is I will say that this first if statement is going to be the condition where we have a tie. This one is going to be where we win, right? And then every other case, if this is where we win and this is a tie, then this else is just going to be when the computer wins. So under what conditions, based on our choice and the computer choice, do we have a tie? Yeah, so that's actually the answer right there. But what does everyone think we should put here? And how should we check if there's a tie? Perfect. Okay, we're going to go with that. I'll just put 2 because they're both strings. All right, let's try this one. So what are some cases? Remember, given rock beating scissors and so on, what are some cases where we win, where the user wins in terms of what the computer chooses and what we choose? Now, it's not going to be greater than or equal to, because remember, the computer choice is not a number, it's a string, and our input is a string as well. So what are some cases? What's one case? Like rock beats scissors, right? How would we actually code that in as being true? If we choose rock, computer chooses scissors, right? Because we picked rock, computer picked scissors, we win. How do we encode that as being true? Exactly, awesome. So I see that. User input is equal to scissors and computer choice equals rock. Perfect. Is that the only case where we win? What if we pick paper and the computer picks scissors? Actually, no, that is a loss for us. But what if we pick scissors and the computer picks paper? Yeah, so there are 2 other cases where we win, right? If let's say if we pick scissors, the computer picks paper. So how would we actually also include that in? I still want it to be part of this condition. Exactly. So we can have an or, and then we can check the other case. Right. So that I think I mentioned user input. So let's say we pick paper, and then what does the computer have to pick? Actually, right, this should be, let me modify that. I think I miswrote that. So our choice is rock, and the computer's choice is scissors, and we win in this case. Or we choose paper, and what does the computer have to choose for us to win when we have paper? Perfect. So they have to choose rock. Perfect. What's one more case where we win? What's the last case where we can win? If we pick scissors, right? So if we pick scissors, what does the computer have to pick for us to win? Exactly, a big paper. All right, let me see, how can I'm gonna put all these like that. I'm gonna do that. So it's all in like one bit, okay? So it's a little bit clearer. Notice how like here it's and, because this has to be true, what we pick, and this has to be true, or, so like this is one outcome, or another outcome, or another outcome. Awesome. Let's just double check these. So rock, scissors, okay, we win. Paper, and they have rock, we win. Scissors, and they have paper, we win. Perfect. So what should we do if we win? Remember something about the score. So what should we do if we win? Yep, we do update the score. But which score do we update if we win? User score, exactly. User score, 1. We're just going to update our score. So we can decrease the rounds. So let me actually do that. I will do that right now. Okay. So what about this other case, else? When do we enter this else case? No, because this is still while all of this is while we have more than 0 rounds, right? So this, when do we enter this else case? Under what condition are we going to enter? Remember, this is a tie, and this is us winning. So what does that mean? What does this else case mean in that scenario? We lose, exactly. So it's neither tie nor we win, so therefore, by definition, we lose. Let's just follow that. We should say that we're gonna do is we're gonna update the computer score +1. We're also just gonna update our round left. All right, so and then here, just say log I, and then here let's say log user wins. Say computer wins with the round rather. User wins the round. Do you see any do you guys see any repetitive code here? There's one line that's being repeated in every one of these cases. Exactly. So this, I'm updating rounds if it's a tie. I'm updating rounds if we win. And I'm also updating rounds if the computer wins. So we can actually remove this from here. We can put this outside of our if statement. And actually, we have that right there. Oh, okay. Awesome. And yeah, how do you feel about that? I think that while loop is done. So the game is done. You know, we get the user input. We determine the computer's choice here. We give some feedback about who chose what, and then we decide who wins. And in deciding who wins, we console log. And if we win or the computer wins, we update the score appropriately. And then we update the number of rounds at the end. So by the time we come back here, we will have one less round, and we'll keep doing that until we have 0 rounds. And so once we have 0 rounds, we'll come to this point here. So we want to print the final score. What I'm going to do to make things clear, I'm going to print 2 of these just to separate out each game from the next. So, right, because we have our rounds, we have like each time this runs, we're going to just get, you know, it's a tie, you choose this, it's a tie, user wins, computer wins. Once the round's done, I'm going to have 2 of these, maybe even 1 of these. And then here I'm going to print the score, because I just want to separate one game from the next. Exactly, the rounds are going to decrease regardless of who wins, whether we win, the computer wins, or even if it's a tie. Exactly. So how might we go about printing the score? And let's not just have the score, but let's like maybe have a little bit more there as well, like final scores. What could we put there? What could we add? Let's use the plus to concatenate them together. So how might we print the score? I wanted to say final scores and then our score as the user score. Exactly. So we have user score. We'll use those 2 variables. Perfect. Okay, so there's something that I'm going to introduce that'll make making these strings a lot easier. So you don't actually need to like concatenate it with variables to get that. And what I'm going to do, I think this is called a backtick. This character, you actually search that up. Correct. Yeah, so it's the backtick key. And so with this backtick key, we can actually very easily add variables to these strings. I will actually write this out. The final scores, user, exactly. So we'll use this like, this is dollar symbol. So you use the dollar symbol, then open and close curly braces. Then we can type in our variable. And notice how it even, if you put U, you can see this is the user score, right? Computer, again, computer score. And there we go. Much easier way of having variables inside of strings, rather than having to concatenate things or use commas. I think this is one way. This is a different way of doing it. All right. So how might we ask the user if they want to keep playing? Very similar to what we did before up here. So we're also going to use a prompt, right? So we're going to say constant, let's just call it replay. And let's ask the user, you want to play it again? Yes or no? Okay. What's something I'm missing here? Like, what if the user types in, we're just going to assume they're always going to type in yes or no. But what if they use a capital Y? How might I account for that? There was something I did previously to make sure everything's lowercase. So what was that? What was that I did? Yeah, 2 lowercase. 2, and then we can just see it's this one here. Perfect. All right, so what can we do here in terms of checking? If, so what's the condition we can check to just have one if? We don't even need an if else. There's something that replay will be equal to tell us that we should exit. Not quite. It will be equal to something that tells us that we want to exit. So remember, the options for replay are yes and no. So what should this be? I just want to have an if statement. I don't want to have an if else. That's a good point, Tarlan. So for that, I would say let's not worry about them putting other inputs in. Let's just assume they're being nice and they just put yes and no. Okay, so I see that's good. So if replay not equal yes, exactly. What should we do here? Other than break, I don't want to use break. What can we do here? Remember, this play variable, if it's true, we play, right? So what can we change here? Exactly, play equals false. Okay, perfect. All right, awesome. I think that is everything for that. We will test this out. Maybe let's even console log right here. Let's say, just say, you know, thanks for playing. Okay, does anyone have any questions before we run this? Like, you know, in general, anything like how we, any particular part of this, like how we determine score, how we got user input, the while loops? No? Okay. Is everyone following along? Like the logic of this? I only see one no. Okay, now I see 2. Line 152. So, okay, I can very briefly I can go over everything from the start, but I'll first explain line 152. So what I did here is instead of using the quotations, I used backticks. And what backticks lets us do is that we don't actually need to concatenate variables with a string. Like I don't need to put like this. I wouldn't need to do example and plus 5, let's say, or if I were to I wouldn't need to do that. Log. Yeah. So it lets us just immediately reference variable here, just using this this $sign and then the curly braces. Yeah, so it simplifies that for sure. All right, so we'll take it from the top. So the first thing I'm doing is I'm setting a variable play to true. And what that does, so play is going to be our way to keep track of whether or not the user wants to play this game. We started as true, so we run it. We can actually run the game in the first place. So, you know, they have to play it at least once. And this is a while loop, which means that the whole game will run. And then we will go back to the beginning, right? So that allows for replays, essentially, as many as the user wants. Now, inside play, we'll set the rounds left to 5. So that tells us that we only have 5 rounds. And we'll set the user and computer score to 0 here. All right, so that's that. Now, this whole thing is just one round. So we're going to skip that. So this is just going to be one round of the game will be handled. When that's done, what we do here, and I'll go back to that, is just we're just going to print out the final scores, and we're going to ask the user if they want to continue. If they want to continue, replay. We won't do anything. So the only check here is if they do not want to play. If they don't want to play, we'll set play to false. And what that does is when we get down here and we're going to go back to the beginning of this while loop, play is false. So we don't run it again. We just exit. So that's why I have this check if replay does not equal yes. Because if replay is yes, nothing happens. Play remains as true. And when we get back to here, it's just true and we start again. Is that bit clear? Just before I get into this rounds section. For sure, I'll explain the tie as well. Okay, good. So now within the round, this is where the bit about ties comes in. So within a round, we're also going to have a while loop, but our condition is while rounds left is greater than 0. So what that means is that this loop will keep running as long as we still have more than 0 rounds left, right? The first thing we're going to do in a single round of us playing against the computer is we're going to get our input. We convert that to lowercase, but we get our input. Then we use a random number generator to get the numbers 0, 1, or 2 randomly. And then based on 0, 1, or 2, we're assigning a choice for the computer where if it's 0, we set that choice to rock, otherwise paper, otherwise scissors, right? 0 is rock, 1 is paper, and then 2 would be scissors. We give some feedback about those choices here. And now this bit, so now we're deciding who wins this round. So if these are equal, it's a tie. Our input and the computer's choice. No matter what it is, like rock and rock, scissors, scissor, paper, paper, whatever it might be, that's equal. Else, if this condition, so each of these cases, these are cases where we win. So if we pick rock, that's what this section is. And because two things have to be true concurrently, we have to pick rock and the computer has to pick scissors. If those two things are true, then we have won the round. So I just put an and, checking for both of those. And then here I put an or. And the reason why I put an or is that really any one of these can be true for us to win a round. We pick rock, computer picks scissors, or we pick paper and the computer picks rock, or we pick scissors and the computer picks paper, right? So if any one of these is true, we have won the round. And so what we do when we win the round is we update our score by 1 and we just console log that. Okay. Now, if this case is us winning and this case is a tie, I'll get to that. So if this case is a tie and this case is us winning, the only remaining case for this else block is where we lose, right? Because we're already handling ties and us winning. So anything other than that is going to be a loss for us. So that's this case where if we lose, the computer score goes up by 1 and we just log that to the console. And then when all of that is done, we decrement our rounds by 1. So we had 5 rounds at the start of this. Now we're going to set the rounds to 4, right? And it makes sense. Like now our rounds is 4. We get back to here. 4 is greater than 0. Yes, so we keep going. And we keep going until we get to 0. And we know that we will eventually reach to 0 because the loop condition, rounds left, is decreasing on every run. And when it hits 0, 0 is not greater than 0. So that's false. So we exit this while loop. And we continue. So we only exit this while loop. We're still inside of this one. We're still playing. And what happens then is that, again, we console log the scores and we ask the user if they want to replay. If they type in anything other than yes, we set play to false. So when this play, the while loop executes once, the one with the play, we'll then go back to the start. And if this play is false, we then exit. If it's true, we have another 5 rounds. Yeah. Does anyone have any questions about that or clarifications? Feel free to type in the chat if you have questions or if what I've explained so far makes sense. So then I can actually run this and we'll see if this works. Maybe there's a bug somewhere, so then we'll have to debug it. Okay, awesome. Perfect. So I'm going to assume that silence means it makes sense from most people. Let's run this. Let's see what happens. Okay, so we're going to choose rock. What do y'all want to choose? Okay, so let's choose rock. There's more rocks than paper. Okay. Nice. So we win. We win the round. So see, because I chose rock, the computer chose scissors, so I win the round. So what should we choose now? I see paper. Paper, okay. Oh no, they won. The computer won, so they chose scissors, right? Okay. Let's try something else. Okay, let's do paper again. Oh, it's a tie. Okay. Scissors? Okay, let's try scissors. They won the round. Okay. For sure. Yeah, there are definitely like things we can do to improve how this looks, but it's working so far. So that's just, we can do that after. Yeah, for sure. We'll put in some console logs and improve that. All right, let's just go with paper. Interesting. Okay, so the final score is a tie. So I won 2 of the rounds and the computer won 2 of the rounds. Yeah. So we actually have a total of 4 rounds. Because remember, we start at 5 and then we don't actually run the 0th round. Actually, no, it was, sorry, my bad. It was 5 rounds, but one of these was a tie. So yeah. And let's say, let's just type in something random. And yeah, because it's only going to play again if I type in yes. So if I type in anything other than yes, it does not play. Perfect. So I think someone mentioned wanting to make this look a little bit nicer, right? So how might we do that? Oh, awesome. Thanks. Yeah. So let's see how, yeah, so the score printed. So Ezra, do you want me to like add in the score whenever you win a round? It says, it shows the scores as well. Okay, let's do that. So let's see, how could we do that? So we can actually, let's do that here. And what I want to do actually is so after each round is, I'll just change this current scores. And what I will do, I'll add this as well. So there's like, right, because this round, right, when this is, you choose this, computer wins a round. So like this bit here, right? I will have the scores and then like just a line at the bottom, just so it's clear. And what I should even do as well, is maybe I should start a new line. A new line is going to be like that. Let's try that again. Hopefully that looks a bit nicer. Let's choose rock. Yeah, what do y'all think I should choose? Scissors, rock. Okay, let's go with scissors. How's that? So that looks a little bit better. The current scores. Maybe I do not put this in. So that looks, it's a bit of a big jump there and there. Paper. Okay, let's pick paper now. So I chose paper. It's a tie. So they won. So the computer won the previous round. This round's a tie. Rock again? Okay, let's go with rock. Oh no, it's still winning. Okay, wait, let's do paper. Maybe it's gonna choose scissors. Oh, that's a tie. Okay. Hmm. Uh-oh. It chose rock, so yeah, I don't think I won a single round. I'll play again. Okay, yeah, let's try that. Let's just do an empty console log. I'm not sure what that'll that might just give one line. Let's try that. Rock. Perfect, awesome. That's a good point, Oliver. That looks much better now, instead of having two lines. And let's choose scissors. Again. That's a tie. If I choose paper. Wow, this is I'm getting some bad luck right now. Okay, well, I won that round, but the computer still won overall. Okay. What we're gonna do is we're gonna take a, yeah, well, what can you do? I mean, it's just randomly guessing, but still. All right, so let's take a 10-minute break and then we'll come back and we'll just take questions on this in more detail.